In the last video, we covered set properties, set notation, and then some basic set operations, and we graphed all that information onto a Venn diagram. Now in this video, we're going to use that Venn diagram to move on to more advanced set operations, and then we'll learn about cardinality. So let's continue asking ourselves even more interesting questions, like what is A intersection B prime? So first, let's see, what's A? A is everything in there. And what about B prime? B prime is everything that is not in B. So everything here and everything here. So where do the two intersect? Well, they intersect right over here at A, B, C. So the answer is A, B, C. Now let's ask something else. What about A prime intersecting B prime? And so now we're getting increasingly more interesting questions. Well, let's just go ahead and think about that for a little moment. This is asking everything that is not part of A, so it would be all of that, and everything that's not part of B, which would be, no pun intended, all of that. So we see that it intersects right over here at JK. Everything that's not part of A, everything that's not part of B intersects at JK. It sort of gets pushed over to this poor innocent JK where it has nothing to do with A and it has nothing to do with B, and now JK over here is responsible. So let's go ahead and write in JK, JK. Now let me scroll down just a little bit. Now let's think about this. What about A intersecting A prime? A, let me write this out. Intersecting A prime. What would that equal? Now let's think about what they're actually asking here. A intersecting what's not part of A. So let's first think about what's A. A is all of that. Now what's A prime? A prime is everything that's not A, so A prime is all of that. Does it ever intersect? Well, they never intersect. So this is what we call an empty set. And we denote that by writing a 0. So now by using the Venn diagram, we've been able to sort out this information so we can see it visually. And we've been able to answer, using this Venn diagram, a lot of interesting questions. But sometimes when we have a lot of elements, the Venn diagram gets too crowded. So let's say the universe were all the letters of the alphabet, right? We would have 26 different letters in here, and this would get really, really big. So instead, we use just numbers, all right? So let me explain here. Let me scroll up to where we just have a Venn diagram. If I were to say, what is the number of A? What I'm asking here is how many elements are in A? Well, we see 1, 2, 3, 4, 5. There are 5 elements in A. Now, what if I ask, what's the number of B? The number of B. Hey, and notice here, I didn't put brackets because this is just a number. It's not a set, it's just a number. What about the number of B? So let's go ahead and see, what's the number of B? Well, B has 1, 2, 3, 4, 5, 6 elements. So the number of B is 6. Now I can start asking some other questions. What's the number of A union B? And we've already established A union B over here, and we could literally just count out all of these things, but let's go ahead and use the Venn diagram. How many elements are in A? Well, we have 1, 2, 3, 4, 5. In B, we have these that are intersect, so we don't want to double count these. All right, so we just count 1, 2, 3, 4, 5, 6, 7, 8, 9. What about the number of A intersecting B? Well, again, that's that little football area right over here. That's going to be D and E. There are 2 elements, and so the number of A intersecting B is 2. And we can go on and start asking some interesting questions, like what's the number of A prime? A prime. And again, this means every element that is not part of A. So we can count 1, 2, 3, 4, 5, 6. There are 6 elements that are not part of A. And we can continue asking pretty much all of these same questions, but writing them in terms of numbers instead of elements. So I hope this video was helpful. I hope it helped you understand how to solve more complex set operations and how we use cardinality, which is when we write the number of elements instead of each individual element inside of the Venn diagram. Also, I hope it helped you understand why we use these Venn diagrams in the first place, which is to sort out this information, make it visual and a lot easier to read so we can solve interesting questions and sort out a lot of information. And this is especially useful in fields like computer science and in STEM fields. So if you have any questions, let me know in the comments below. I will be happy to address them and answer them. And as always, stay positive.